Okay, so good day to all of you. So in this video tutorial, you're going to learn the functionality of a push button. So we're going to create a simple project that uses a push button and of course, the corresponding Arduino sketch for it. So let's start. So again, we're going to set up our electronic components. But before that, though our Arduino does not have any power source yet, we're not connecting it yet to the USB port. But again, it's a very important reminder or a practice that you should have no metallic objects that you are wearing, such as jewelries, so that to avoid electrocution or being grounded because of the stored energy of the components, if there is. So let's start. So what are the materials that we need for, of course, our simple project that uses push button? Of course, we have the star of this simple project is we have the push button. So this push button is actually, maybe you can tell that it's actually the most common and the oldest that is used, because there are many variations now in the market that uses other push buttons, actually bigger. So you can see this is very small push button. So this push button has 4 pins. Actually, in our project, in this example, is we're just going to use 3 pins and then leave the other pin, or this pin, one of it will do not have any connection. So this is our push button. So as you can see, so we have these 2 points, meaning that these 2 are internally connected. So this is also internally connected. So when you're going to press the push button, so it has this sound. And then once you press the push button, so this side and this side will have a connection once the push button is pressed. Okay, unlike LED, the pins of the push button does not have any polarity. So I'm going to illustrate you later that do you need any convention that this should be the ground, this should be the power source, or since there is no polarity, can you assign it anywhere? So I'm going to illustrate that, or I'm going to show it to you when we are already setting it up in the Arduino board. So aside from our push button, of course, is we have our resistor. So the function of the resistor in the LED is it does not allow the LED to draw power to itself or too much power, so that to avoid burnout. So for this, our push button is an input. It is an input device. So our input component. So for this one, so we're going to use a resistor as a pull down resistor. So again, I'm going to discuss to you, so what's the use of the pull down resistor. And then of course we're going to use wires again, DuPont cables. And then of course our simple project will not be possible if there is no Arduino board. So let's start our setup. So first is our push button. So our push button is you can situate it in the middle. Okay, so that's already set it up. So again, these 2 are connected, internally connected. And then if you're going to press the push button, so this will be connected if the button is pressed. Okay, so where are we going to assign our power source and the ground? Actually, if you're going to assign for power source and ground, make it sure that they are on both sides. Example, if you decided that you're going to put your power source and ground here, so they should be together here at this side, not in this way. So there will be and it's not an error, but maybe your project will not behave as expected, or you will have unexpected results. So left or right is your ground. Actually, it depends upon you. So just remember where did you assign your ground and the power source. So let's put a DuPont cable for our power source. Okay, so put the railing for the positive and negative railings. Let's put, for example, this is our positive. So let us make it red so that you can easily distinguish that it is for the power source. So we put it in the 5 volts, and then next is we have our ground. For the ground railings, of course, okay, you can put it here. Again, you have 3 sources for the ground, so they're all just the same. So let's put it in, okay, the ground. And then next is we have to put power source and ground for our push button. So what if you decided that this will be my ground? So if that will be your ground, so again, we need our resistor. So we're going to use this as a pull down resistor. So what does the pull down resistor do? So for pull down resistor, that's why it's called pull down, because push button, if you do not have a pull down resistor and if you power up your project, the problem is your push button will have unexpected state, or it doesn't have a definite state. It's floating, or it can start as low, or it can start as high, or on or off. So to avoid that, and then to illustrate a real world behavior of a push button, in which if you're going to power up, your push button must be off. Okay, so let's put our resistor here. So again, this will be our pull down resistor, so this will be connected to our ground. So let's put a wire. Again, you have to make sure that your wires are aligned or properly connected to avoid unexpected results for your project. So let's put it in this is the for the ground. So okay, and then let's assign our power source for our push button. So since this is already your ground, of course, this pin is your power source, and then let's connect it to the power rails with a for power source connected. So the only cable that we miss is the for the pin assignment of your push button, in which your push button will be giving or storing its data in what pin. So in this project, so let's connect it to pin number 12. So again remember, since this is your ground, your pin assignment should be connected across, not here. So let's connect it in here. And then again, as I've said, let's put it in pin number 12. So we've already set up our push button and its corresponding connections. So we are already ready to code our, of course, to code our Arduino sketch for this push button. So okay, let's go to our coding part.
Okay, so we're already in our Arduino IDE. So since we've already set up our push button in the breadboard for in the Arduino Uno, so we have this Arduino sketch to illustrate or to show you how the push button works. Okay, so let's define our push button. So, number sign, define, and then button underscore 1, all caps. And then, since in our electronic setup, we've assigned our push button in pin number 12. So, let's put number 12 for pin number 12. And then after we defined our push button, so let's go to void setup. So, since we're going to use again our serial monitor to show the status of our push button, so let's type again serial.begin, 9600 for the baud rate, okay? And then let's initialize our push button. So since push button is what? It is an input device, so let's initialize it by using pin mode, then button underscore 1, and then again, since it's an input device, you should put input. Okay, so we've already declared for the serial, so because we're going to use the serial monitor, and then our push button as an input. Okay, can you make this an output? No, because again, the nature of push button is an input device. If you declare it as an output, okay, then it will not work because our push button does not display status or does not actuate. So again, push button is an input device. Okay, next is we have in the void loop. Okay, in our void loop, so let's declare a value. So int val is equal to digital read button underscore 1. Okay, what does this code mean? So, you're going to read the status of the push button by means of digital read. So, digital read only reads values since it's digital. It's either high or low, 0 or 1, on or off. So, whatever the status of the push button, it's either on or off, it will be stored inside the val, which is of integer data type. So this is the meaning of our line of code here. Again, whatever is the status of the push button, may it be on or off or pressed or not yet pressed. So pressed means 1 and then not pressed is 0. It will be stored inside the integer data type. The name of this data type is val. And then next is we're going to use an if condition. So if val is equal to high, so you can see this is we're using equal sign, but for this one is we have equal. So this equal sign here is an assignment operator, meaning again, the right side will be assigned to the left side or stored. So while this double equal sign means you have this comparison. You're going to compare if the value that is stored inside is high, which is 1, or 0, which is low. So we're using the word high so that we can better understand it, meaning if the button or the push button is pressed, so that will be if value is equal to high. So that is the equivalent of in a real world explanation. So if value is equivalent or equal to high, meaning if the push button is pressed, so we have this line of code. So in our serial, that print ln, so button high, okay, means that this line of code, if the push button is pressed, then the serial monitor will display a message button high, meaning the push button is pressed. And then we have another. Okay, so we'll have an error here because I forgot to put a curly brackets. So let's put the other curly brackets and then else. Okay, so we have an else statement. So we have, okay, so we have serial dot println button button low. And then, okay, so it has generated the corresponding right curly bracket. Okay, so let's just decrease the font a little so that this can all be displayed. Okay, another one. Okay, so again, if the push button is pressed, serial monitor will display a message of button high, meaning the push button is pressed. So what is this else statement? Meaning, if the button is not pressed, the message will be displayed is button low or button off. And then we already have these two right curly brackets. Okay, let's check if our Arduino sketch has errors or is the encoding correct. So let's verify. Again, it will be saved. Okay, once you verify your Arduino sketch. So we have push button, for example. Let's just name our project as push button. Okay, so let's wait for it to compile. Okay, no errors. So, we are ready. So, we are finished with our Arduino sketch for our push button. So, we are already ready to run it and set it up in our computer, our Arduino Uno with the push button setup.
Okay, so we're ready to upload our push button Arduino sketch. So let's see. But make sure that the corresponding Arduino Uno board and its corresponding COM port is recognized by the Arduino IDE. So let's upload our Arduino sketch. Okay, let's wait it to be uploaded. Okay, there is no error. So let's see the serial monitor. Okay, as you can see, the initial value of push button is low or it is off, which is, in this example, it is correct because I haven't pressed the button yet. So that's the use actually of our pull down resistor. So it initiates the push button's state into off or low. So let's try pressing the push button to see if there are changes in the state. Because based on the Arduino sketch, that if you're going to press the push button, it will display button high. So let's press. Okay, so I'm pressing the push button. Okay, so I'm pressing it. So it means that when I press it, so that the serial monitor's message changed to button high. And then when I release the push buttons button, so it will return again to low. So our design is correct. So what are example of the behaviors that you want to show, for example, with our Arduino board? Example, you want, what if, your curiosity sinks in, since that our pin is across the ground, what if we connect it across our power source? So let's see, let's just change, let's put it across our power source. So what will be its behavior? So if you changed it, so what can you see? So you can see that the status is unstable. I'm not pressing anything actually, but when I press, okay, it still recognizes that I pressed the button, but then there is an expected error because once I did not press the button anymore, why is it the status still high? So that's the common mistake, is you're putting your pin assignment across the power source. So it should be in our ground. So let's return it to the ground. So when you press it again, okay, it is functioning as expected. When you press the button, it will display the button high message. So it's not a mistake. What if, for example, since this is your expectation that if you're not going to press the button, so the button is low, let's interchange. For example, put our resistor to the power source. So we did not need to remove the resistor, just interchange the wires. So, okay, let's interchange our ground in here and then our power source. So our power source will have the resistor. So what is the behavior? As you can see, for the behavior, it becomes button high, meaning that the resistor, which is earlier it is a pull down resistor, it becomes a pull up resistor because you connected the resistor in line with the power source. Okay, let's press the button again. So if you press the button, it has an opposite effect, just like the compared to the original, because when I press the button, the message becomes button low, and then when I release the button, and then it is button high. So for common push button, it's not just a good practice. It's that if you really have a very good reason to make it its opposite effect, pressing it will turn it off. But then again, as push button, so let's return it again to its original setup. So again, I interchange it again. The resistor becomes the pull down resistor. So again, let's press it again if it is working. Okay, so this is the original setup for our simple push button. So I hope that you've learned something from this tutorial, that you can use push button also in our Arduino projects. And then of course, do not forget to subscribe to my channel. And then if you do have any questions, please feel free to comment below. So again, thank you very much and good day.